OpenRules is a well-known decision intelligence platform. For over 20 years, it has been helping organizations in finance, healthcare, telecom, and other industries to make fast and reliable decisions. One thing that really sets OpenRules apart is how smoothly its rule engine works together with constraint and linear solvers. Because of this built-in integration, subject matter experts with no programming expertise can take advantage of advanced optimization. That means OpenRules models compare many possible outcomes and choose the best one, instead of giving just a single decision like most traditional rule engines. Overall, this plus built-in machine learning makes OpenRules a strong and distinctive platform for building intelligent operational decision services. However, until recently, as with most traditional optimization tools, OpenRules models had a hard time finding the best decisions when uncertainty was involved. People who rely on these models for everyday operational decisions often point to this as a major drawback in real-world situations. For example, here's how Adam DeJans describes these issues. Optimal solutions don't really exist, at least not in the real world. They exist on whiteboards, homework problems. They exist in decks where nothing changes after the slide is finalized. But in practice, demand changes. Inputs and predictions are wrong. Constraints move. Someone makes a call upstream that blows up your nicely prepared plan. So, what was optimal 5 minutes ago isn't anymore. That's why practitioners stop caring so much about whether a solution is the best one. What they care about is, was it a reasonable decision given what we knew at the time? How bad is it if we're wrong? How quickly can we adjust? When it's time to actually make a decision, users have a much clearer understanding of real-time constraints and limitations than even the most advanced decision model can capture. So, users need a way to share these real-time constraints with the model and help steer its search for the best solution by quickly exploring multiple alternatives. In these situations, optimization isn't just about finding a single perfect answer. It's about creating a flexible decision process that becomes progressively less wrong over time. The question is, how can we effectively address these real-world needs? The latest OpenRules interactive tool, the Decision Playground, represents a significant practical step toward bridging the gap between theory and real-world decision-making. It offers an intuitive graphical interface for business analysts, providing them with the opportunity to use existing decision models as is, add real-time constraints, explore alternative outcomes to find the most suitable decision. A user who is a business specialist enters a new request and asks Decision Playground to minimize or maximize the selected optimization objective. A user can quickly add additional constraints, called filters, to tune the decision model to the reality of a concrete decisioning situation. While conducting these experiments, a user saves decision candidates into the decision pool with possible explanations. Inside the pool, a user visually compares different decision candidates and chooses the decision champion that best fits the current situation. This decision can then be exported for future use or future decision tracing. When the number of decisions is relatively small, users can also browse all available options using the buttons First, Next, Previous, and Last Decision to choose the best one without invoking any optimization. You can learn more about Decision Playground by downloading it from the OpenRules website. The evaluation is free. It includes many examples you can explore, and you can even experiment with finding decision champions for your own decision model in different real-world scenarios.